have f of x equals 1 divided by the square root of x plus 1. And we are asked here to find two functions, the inner, let's say we're going to call it h of x, and the outer, let's say we're going to call it g of x. Such that, so find these two functions such that f of x equals g of h, g comp h of x. So I want to find the inner, and I want to find the outer. There is more than one correct answer here. I can come up with the correct answer, and somebody else can come up with the correct answer. Any suggestions for the inner?
Root of x?
Say it again.
No, I was
You were close.
I was going to say root of x, but
Right, but
root of x plus 1?
correct. I completely agree with that. So once I have a number here, which is my h of x, what will be the outer, which will be denoted by g of x? That's it. That's it. Any questions? Do we remember this? We need to look at another example.
I think I get it.
We need another? Anyone? Yes? Okay. So let's look at f of x. Let's say the absolute value of x squared plus 2. We need the inner, which is h of x, and the outer, which is g of x. The inner, please.
X squared plus 2.
Agreed. Once I have a number here, what will be the outer?
Absolute value of x.
Is this clear? Yes? Okay. Determine if a function is one-to-one. Find the inverse of a function using the graph. And find the inverse of the function and use the graph of a one-to function to graph its inverse. Should you look at how to find the inverse of a function? The 4-step procedure? Okay, very good. So can anyone give us a linear function? Is a linear function one-to-one?
Yeah.
Yes, it is one-to-one. Very good. So can anyone give us a linear function?
Y equals x plus 2.
Okay, let's say x plus 2 over 3. Is this a linear function?
Yeah.
Of course, there is no x in the denominator. It's just a number, so it's linear. Good.
Like a few x.
Step number 1. It's not considered rational because it doesn't have x in the denominator. Very good. Step 1.
Multiply by 3.
Replace f of x by?
F. Y.
Exactly. In step 2, what do I have to do in step 2?
Reverse the operation.
Exactly. Reverse the variables because x becomes y and y becomes x. So x equals y plus 2 over 3. In step 3, I need to solve for
Solve for y.
exactly. So now, Tom, you already told us what to do.
Undo the procedures, multiply by 3.
Good. So this is 3x equals y plus 2. We multiplied both sides by 3. Now what?
Subtract 2.
Good. So I have y equals 3x minus 2. In the last step,
Replace y with f inverse of x.
that's it. This is it. So I determine the inverse function of a one-to-one function. If I say to you, for example, f of 3 is 2 and f is 1-to-1. I'm not giving you any other information, but I want to ask you, how much is f inverse of 2? Very good. Because if the ordered pair for f is 3, 2, the ordered pair for f inverse must be
Let's trade places.
2, 3. Good. Okay. Distance and midpoint formulas. And the circle. We want an example from distance, an example from midpoint, and a circle. Is that a yes? Okay, so give me two ordered pairs so we can determine the midpoint and the distance. -2, 1, 4, -3. The midpoint. Sum of x's divided by 2. Please add them up.
1.
Yes, so when you add them up, you get 2. 2 divided by 2 is 1. Add these up, please.
-1.
So it's -2 divided by 2 is -1. So the formula is the sum of x's, the average of x's, in other words, the sum divided by 2 and the sum of y's divided by 2. Now let's determine the distance between these two. I have to write the formula. Anyone reminds us the formula? Would like to remind us the formula?
x2 minus x1 parentheses squared plus y2 minus y1 squared.
Perfect. Will I ever see d is the square root of -19?
You could, but then if that were the case, no, you couldn't.
I will never see this, right?
Mm.
Because this is what type of number?
Positive.
Always.
Because
This
it's
is
being
what type of
squared.
number? Exactly. What type of number is this?
Positive.
And I'm adding a positive to another positive. So this will never happen, correct? Please. Okay, good. So I'm going to write them underneath. It's up to you. The method is, I prefer this because it's easier for me, but it's up to you. So I have x2, 4. I have x1, -2. I have y2, -3, and I have y1, which is 1. 4 minus -2. 6. 6 squared. Awesome. Plus -3 minus 1.
4.
-4 squared.
16.
That's it. So 36 plus 16. So is the square root of 52. If you want to approximate it, you can. Let's look at a circle. Let's say, for example, we have a circle with a center -2, 0, and a radius of 4. Can anyone give us the equation of the circle?
I think I can. Y equals 4.
No,
Oh,
because I cannot write y equals.
half of x? Or
I cannot write y simply because it's not a function. It's two functions.
well,
It's the function from above and the function from below.
then let's
Okay,
see.
before you say anything, here's the equation.
That's what I was trying to say, ignore the y equals thing, and I was just.
I'm ignoring it. So then what do I write?
So then it is
Let me write the equation here for you. X minus h squared plus y minus k squared equals r squared.
everything is equal to 16. X minus -2 minus what would be h?
It's x plus 2
Wow.
y squared.
That's it. So this is our negative,
H.
this is our h is -2, and this is our k, which is 0. That's why we have this. What if now we're asked to graph it? What do I have to graph first?
The center.
Awesome. So -2 comma 0 is this. And what is the radius? And I have to create 4 points. 4 to the left, 4 to the right, 4 up, 4 down. So 4. 1, 2, 3, 4. 2 more here. 1, 2, 3, 4. And 1, 2, 3, 4. And now I will connect and extend. This is the circle with a center at -2, 0 and a radius of 4. Okay. I think we exhausted this. The graphs and polynomial functions. We use the long divisions not today though. If you want me to review a long division, I will gladly. We reviewed the remainder theorem and the factor theorem. We reviewed rational functions. We reviewed all polynomial and rational inequalities. Now I would like you to say, I still need a problem like this, and a problem like this, and a problem like this, because I'm not sure of those. I have 6 more minutes. So I want to use them efficiently. So from anything and everything we reviewed today, I would like you to say, I'm not so sure about this problem. Or not say anything. Just say, I want to see another problem of this type.
Can we do one more rational graph?
Yes, absolutely. We can choose one. You want me to choose one from the book, or yes?
Can we just do that like first function we had on that one, so that 2x minus 1 over the x squared minus 1?
Yes, very good. So f of x was 2x minus 1 over, what was the denominator?
X squared minus x minus 2. Or,
So it was x minus 2x plus 1?
Yeah.
Okay, very good. Was it? You said x squared minus 2.
minus x minus 2, so yeah, that's what it would be.
So it was x squared minus x minus 2, correct? Okay, perfect. Good. So I know this is type
2.
Yes, indeed. So when I get my chart going, I will immediately put 0 here as the end behavior, and this is y equals 0 horizontal asymptote. Oh, also from the work that I returned today, if you have questions from that, I posted solutions. I still have to post one more, which is the work from last time. I have it because I graded them and I returned them to you. So, but everything else is posted. So once I know that this is type 2, I know that the horizontal asymptote and the end behavior is 0 right away. Okay, now I want the domain. What is the domain of this function?
All real numbers except. No? Yeah, except.
We discussed those. Yes, indeed. So -1 and 2 undefined. What do I conclude about x? Yes, I know you're way ahead of me. That's wonderful. So what do I know about x equals -1 and x equals 2 right away?
Vertical asymptote.
Correct. Do we all agree with vertical asymptotes? For both? Okay. Why? Can anyone remind us why? Because they don't disappear. They stay in the final simplified form. Correct. Good. Which means right away I know infinities. Correct? What I don't know, though, is I don't know whether they're signs, positive and negative. I know once I write that they are vertical asymptotes, I have to copy this immediately. But I don't know the sign. So I'm going to use -1.1 and -0.9, 1.9 and 2.1. -1.1 plugged in the top. What do I get? Perfect. -1.1 plugged in x minus 2. Perfect. -1.1 plugged in x plus 1. 3 negatives, and I know the sign here.
Positive. Not negative.
Good. -0.9, the top. Perfect. -0.9 minus 2. But now, -0.9 plus 1. 2 negatives. Done. With 1.9, the top. 2 times 1.9 is 3.8. 3.8 minus 1. Perfect. 1.9 minus 2. And 1.9 plus 1. Only one negative. And with 2.1, 2.1 times 2 will be 4.2 minus 1, positive. 2.1 minus 2, and positive. Okay, what happens when x is 0? From the expanded form, was this on the orange? Yes, it was on the orange. So when I determine the x-intercept, the y-intercept, it's easier to say this is 0, this is 0, this is 0. So what will be the y-intercept when x is 0? Very good. And the final question is, when is this function 0? When is a ratio 0? When will this equal 0? When the top is 0? When is the top 0? When is 2x minus 1 0? Move 1 divided by 2 and divide by 2. So 1/2, comma 0. This is, yes, please.
So when you're finding when you're plugging in x equals 0, you're going back to the original thing.
It's easier.
It's easier, right?
But I can do it here.
You can.
So this is 0, and the top is -1. This is 0, and the bottom is -2. This is 0 plus 1. So multiplied by 1.
Okay.
And I still have to get 1/2. But if when it's expanded, it's easier to plug in 0.
Right.
The top is -1, the bottom is -2.
Okay.
Yes. So now we're trying to make sense of this information, summarized in the chart, and then we can graph it. From approaching 0 down to -infinity. From positive infinity, crossing at 0, 1/2, crossing at 1/2, 0, and going down to -infinity. And here from positive infinity to 0. Believe it or not, this is my last page. I have to run and get more paper. So when I graph a function with asymptotes, I have to graph the asymptotes first. And they are, this is an overkill, there is no need, y equals 0. And this is -1. And this is +2. So from 0 to -infinity. From positive infinity, 0, 1/2 is this point, 1/2, 0 is this point. So something like this, a little bit too close. And from positive infinity to 0. So this is the graph of the function